Assalamualaikum warahmatullahi wabarakatuh. My name is Harraz bin Abdul Wahid. Today, right now, I'm going to explaining about our case study. In this case study, we need to find the depth of water in the water tank when the volume of water in the spherical water tank is 30 meter cubic. Given the general equation, which is volume equal to pi h square times 3r minus h divided by 3. This equation is the after rearranging the general equation to get the FH, and by substituting the value of R and volume, we get the finalized general equation, which is this, and this equation will be used in my method, which is bisection method. The bisection method needs to have two initial guesses, which is SL and SU. These initial guesses are important to get the SR, as the SR equation can be get as the SR value can get by using this equation, which is SR equal to SL plus SU divided by 2. For the specified tolerance, I use 0.1%. Next, I will explain about the coding in the MATLAB. So the second line is about where I put the equation, and the fourth line is where the HL, HU, IMAX pre-specified value and HR as value are set. So I use HL as 1, HU 3, IMAX 10, where the max iteration is 10 and initial HR is 0. If FL times FU greater than 0, it will display the function has the same size at point HL and HU as it will display this in the equal to HR, and to get HR is HR plus HU divided by 2, and to get error is absolute HR minus HR all divided by HR times 100, and it will display I, HL, HU, HR, FR error in the table. So if FR equal to 0, it will display the roots, and if I equal to IMAX, it will show that the iteration is not obtained during the 10 iteration. If FL times FR less than 0, HU equal to HR, and as HL equal to HR, F1, FL equal to FR. And lastly, it will show the approximate solution where it is the root. So this is the data iteration compute by the MATLAB. It has 10 iteration, as I said, I max 10, and the approximate solution is 2.025391. Thank you.
Assalamualaikum. I am Rahman. I want to explain the case study about our assignment, which is assignment 1. So we are designing a spherical tank to hold water for a small village in a different country. The volume liquid it can hold can be computed as V equal to pi h square bracket 3r minus h over 3, where V is the volume of the water and the depth h is the depth of water and the r is the radius of water. So if r equal to 3 meter, so what depth must the tank to be filled so that it has 3 meter cube? So in this question, I use false position method to determine the answer. So the equation to be solved is like I said before, the pi r h square minus 3 pi over 3 h cube bracket over minus volume. So if we insert the value of r equal to 3 and v equal to 30, so the equation will be 3 pi h square minus 1 over 3 pi h cube minus 30. So the method that I chosen in this for this case study is first position method. So this method is one of the most effective used method to find the root of the equation. This method requires the lower bound and the upper bound in order to find the estimated root. So to find the estimated root, we use the formula xu minus fxu times by x initial minus xu divide by fxl minus fxu. So next I will explain about the coding that I use for this method, which is false position method. So the coding I using Octave because my MATLAB my laptop cannot support MATLAB because of the storage of my laptop isn't enough. So I using Octave online. So from what I found is Octave online is quite similar to the MATLAB. Because when this coding my friend uses on the MATLAB, so it would the same. It will just work the same as the MATLAB. And also, but this when it come to the output, it's a bit different because maybe it's something that we don't know about the coding that to change the way of the output. So for the coding, so the equation, we put the equation first, f equal to 3 pi x times x times by x of power of 2 and minus 1 over 3 pi x and the power of 3 minus 30. So for the graph, we just take from the x equal to 0, 0.1, 0.01 and 0.05. So for the variable xl, I use xo and 0 because we start from 0, and for the xu we use 3. So for the iteration, we put the max iteration for 20 because if the coding keep calculating until infinity, so the output will be miserable. So we put the imax to equal to 20. So for the approximation error, which we put 0.5. So for the XR equal to 0 because we don't calculate it yet. So for the FL equal to FUR. So for the calculation and display, this is the coding that I've used. So this is, I think, which a bit more reasonable. And for the coding for I equal to 1, so for the iteration 1, so XR all equal to XR. So when the new we obtain the new XR, it will replace the XR all. So we put the formula of XR in here, which XU minus FU times XL minus XU divided by FL minus FU. So FR equal to FXR. So approximation error, absolute XR minus XR all equal to XR for the formula we use for this approximation error. So I'm using if and properties, so we can get the output such as, so for the output, this is the iteration, lower bound, upper bound, and then the solution of XR, and the FXU, FXR, FXL, and expression error. So we got the answer in the iteration 4, which is XR equal to 2.026687. So that's from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Faiz bin Abdullah. Now, I will explain about the fixed point iteration method that was used to solve the case study. In this case study, we need to determine the value of H, which is the depth of water that can be filled until the volume reach 30 meter cubic. So, since I use fixed point iteration method, we need to have initial guess, which is x0 or xi, and we need to find the root, which is xi plus 1. Xi and xi plus 1 value can be obtained by using this equation. In this case, xi is hi and Si plus 1 is Hi plus 1. By transforming the original equation, the equation of Hi and Hi plus 1 became like this after inserting the value of radius and volume. For pre-specified tolerance, the epsilon s is set to 0.5%. Now, I will proceed to explain about the fixed point iteration method coding in MATLAB. So, this is the coding for fixed point iteration method. Line 2 is the function of hash, which is square root 10 over pi plus hash cubic over 9. For the first iteration, it is set to 1. The initial guess is defined as hash naught is set to 1. The estimate root hi plus 1 is defined as hash 1. Hash 1 can be calculated by inserting the value of hash naught into the equation. The pre-specified tolerance epsilon s is set to 0.005. The approximate error epsilon a is defined as ERR can be calculated using equation absolute hash1 minus hash naught over hash1. The next line is for displaying the title and the values calculated. In while loop, the code will run until epsilon a is smaller than es. Then, the estimate root will be obtained. Now, I will run the script. As you can see, by using fixed point iteration method, it takes 5 iterations to find the estimate root. The estimate root for this problem is 2.02448 meters. So that's all for this method.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nazrul and I will show you how to solve my case study using Numerical method. In this case study, I need to find the height of the water in the spherical tank if the water is filled by 30 meter cube of water. for using Numerical method, I need to derive the function, get initial guesses. As for this case study, I take 3 meters as my guess. By using this formula, I can get the xi plus 1 value. And now I will explain to you how I code this problem in MATLAB. The first 2 lines, I introduce the function as f and f1, where f is the original function and f1 is the derivation. So, and then I introduce my initial guess, which is 3, and where the pre-specified error is 0.005, and this in the 6th line, this is the how I find the h plus 1, the hi plus 1 value, and this is how I calculate the error, where the value of h1 minus h0 over h1 will print all the value of h dot, h1, fh dot, fh0 and f1 h0 and the error. While the error is greater than epsilon, the coding will run and updating the value of h dot and h1 by using this formula. And then when the error finally lesser than epsilon, this message will come out and give the root, where the root is the height of the tank, the height of the water in the tank. So, and now I will run this coding. So after run the coding, this is how the command will come out, and then it give The final root is 2.026906 meters. So this is my final answer using Newton-Raphson method.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Adib bin Ahmad Zaidi, and today I will present my case study using secant method for this kind of problem. So the case study is you are designing a spherical tank in figure Q9 to hold water for a small village in a developing country. The volume of liquid it can hold can be calculated as V equals to pi h squared 3r minus h over 3, where V equals to volume in meter cube, h equals to depth of water in tank in meter, and r the tank radius in meter. If r equals to 3 meter, to what depth must the tank be filled so that it holds 30 meter cube of water? Use 3 iterations of the false position method to determine your answer. Determine the approximate relative error after each iteration. So the equation to be solved is fh equals to pi r h squared minus pi over 3 h cube minus v. So using secant method, and I have programmed it. So in this body, the 3 first line that you can see is for we are initializing MATLAB. So I assign A as an input to a function where we input the function ourselves. So we assign the function with variable A, and for the 7th line is f, where for function f we want to call the function that we entered just now, so we put it in inline library function. So as for x1 we enter the first point of guess interval, for x2 we enter second point of guess interval, for n we enter allowed error in calculation, or in other words we call it as pre-specified error. So in this case I use 0.5% for the allowable error, and we initialize iteration to 0. So after we enter all this number, it will display for the x0, x1, fx0, fx1, and the approximate error, approximate relative error. Okay, so for this loop, I equals to 3 to 100. So this is the secant method formula. So this for xi plus 1, which is our estimated roots. So as the number obeys the instruction, the iteration keeps on counting, and this is where our approximate relative error is calculated, where we absolute the value of xi minus 1 over xi times by 100. So it will give the answer in percent. So after we calculate all of the items, it will appear that the new x0 is x2, the new x1 is xi, and the new fx1 is fx2, and the new fx0 is fx2, and the new fx1 is fxi, and the approximate relative error. So there is if loop. So the if loop says if the approximate relative error is smaller than pre-specified error, so the program ends, where we take the root as xi, and iteration stops where if it's obey this instruction. So let's see how it goes. So enter function. pi times 3, which is to give a radius, times x squared, close bracket, minus open bracket, pi over 3, close bracket, times x cubed, close bracket, minus 30, which is volume of the whole tank. So there we can see the inline function. It was being called. So now we have fx equals to pi times 3 times x squared minus pi over 3 times x cubed minus 30. So enter first point of guess interval, we take as 0. Enter second point of guess interval, we take 3. And allowable error is 0.5%, which is 0.005. Enter. There you go. We have 5 iteration to reach the estimated root of 2.0269. As you can see, in the 6th iteration, the number is constant. So we took iteration to 5, and elapsed time is 67 seconds. We got from this command, which is TikTok, where it can trace our interval time in the program. So that's all from me. Thank you.
Based on all the methods that we use in this case study, we can conclude that force position method is the fastest to reach its final value, which only requires 4 iteration.